All right, we're gonna find limits using factoring, conjugates, and trig identities before lunch. We might extend it into after lunch a little bit, but okay. So factoring. If we just straight substitute in here, what's negative 7 times negative 4? Negative 28 plus 28 is 0. If we put in negative 4 in the denominator, we get 16 minus 4 minus 12, which is 0. We get 0 over 0. Okay, and most of you guys would say, well, that does not exist. Oh, but this is Calc class. All right. So we can take one more. If it's 0 over 0, it's called indeterminate form. Which means we can probably find a solution out of this sucker. So let's do that. To find a solution, we have to factor. Oh! Yeah, I'm frozen. Boom. Indeterminate form, 0 over 0. So let's factor. Okay. So how's the top factor? We can take out 7 and we get x plus 4. How does the bottom factor? X and x plus and minus. Minus 3 plus 4. So then what can happen? These can cancel. So now we're taking the limit at x approaches negative 4 of 7 over x minus 3. If we plug them in, we get 7 over negative 7, which is negative 1. And that is our limit. Okay. Now, do you want me to prove that to you?
No, that's okay. I don't need to know.
I really want to, though. Okay.
Are you recording for Whitney?
Yeah, I'm recording for Whitney. Evelyn does, yes. If we go to Desmos, what is Desmos? Well, it has a wonderful graphing calculator. Yes. And so if we put in this function, which is right here, 7x plus 28, 7x plus, oh, I better use parentheses, 7x plus 28 over x squared plus x minus 12. So, as we approach, where were we approaching? Negative 4. As we're approaching negative 4, where is this approaching from both directions? Negative 1. Okay? Negative 1. So, since what happens here, or what happens in the graph, is as it goes down like that, there's a hole in the graph. Desmos just doesn't show that hole, but there's a hole in the graph there. Okay? So, let's figure out this one. If we put in a 2, we get 0 on the bottom, probably 0 on the top too. So, can we factor this at all? What could come out of the top? X squared out of the top, so we get x squared minus 4x plus 4 over x minus 2. Anything else I can do on the top? X minus 2 and x minus 2. And one of the x minus 2's cancels with the x minus 2 here. Okay, so the denominator is just 1. So you know it's going to work. If you stick a 2 in, 2 squared is 4. 2 minus 2 is 0. Oop, 2 minus 2 is 0. So it's 4 times 0, which is 0. So the limit is 0 for that one. On this one, what's our factoring that we would do? x squared comes out of both the top and the bottom. On the top, we get x squared plus 2x minus 3. On the bottom, we get x minus 1. Any more factoring we can do? Because these cancel.
Yeah, on the top, you can do minus 3, or plus 3 minus 1.
X plus 3, x minus 1. The denominator is x minus 1.
You have x plus 3, and then you can sub in a 1, and then 1 plus 3 equals 4. And that's it.
There you go. So now we figured out limits using factoring, if there's a factoring situation. Okay. If we stick in a 1 here, we get 5 times 1 is 5, plus 4 is 9, the square root of 9 is 3, 3 minus 3 is 0, 1 minus 1 is 0. 0 over 0 is, again, indeterminate form. So we should be able to find a limit most of the time when it's an indeterminate form. If it's something else over 0, it's probably not going to have a limit. Okay? Okay, so how are we going to do this? Well, the way we're going to do this one is take the conjugate of the numerator this time, because that's where the square root is involved. So we're going to take the conjugate of the numerator and multiply both the top and bottom by the conjugate of the numerator. So we're going to go the square root of 5x plus 4 plus 3 in both the numerator and denominator. So in the numerator, if I FOIL this, what's the square root of 5x plus 4 times square root of 5x plus 4? 5x plus 4. When you square a square root, you get what's underneath. Okay? Outers and inners in conjugates always cancel. So it's 5x plus 4 minus 9 over this dreaded thing. So it's x times 5x minus 4, the square root of 5x minus 4. I'm going to leave it like that. Outers is going to be plus 3x. Inners is going to be minus the square root of 5x plus 4. And last is going to be minus 3. Okay? So if we stick, would this help? Well, just watch. If you put in a 1, you get 5 times 4 minus 9 is 0. In the denominator, put in a 1. You get 1 times 1, because 5 times 1 is 5, minus 4 is 1, the square root of 1 is 1. Plus 3 minus this again is 1 minus 3. Oh, shoot.
Shouldn't the square roots on the bottom be 5x plus 4? So then it would be 9, and then it would be 3.
5x plus 4. Thank you. So that's 3. And then minus 3, but still it's, yeah.
The limit does not exist.
Mr. Bierschbach.
What'd you do?
Okay. I think I did something here. Okay. Don't plug it in yet, because you still get 0 over 0. So in the numerator is 5x minus 5. Your denominator, okay, if we combine like terms, you get x times the square root of 5x minus 4 minus the square root of 5x minus 4. Well, actually, let's get rid of this and leave them as not multiplied through, because this is what will help us out. Okay? So on the numerator, you multiply through. Denominator, you don't. Now I remember. Sorry, had a brain fart. That'll happen a lot in here. You'll actually see Mr. Bierschbach as kind of an idiot some days, but it is what it is. Okay, so now what can we do in the numerator? Take out a 5 and we get x minus 1. In the denominator, x minus 1, the square root of 5x plus 4 minus 3. The x minus 1's cancel. Now if we stick in the 1, this should be plus 3. So it's 5 over 3 plus 3, which is 5/6. And that's our limit. Sorry, that was difficult. Let's do another one. Okay, if we stick in a negative 1, we get 0 over 0, indeterminate form. Okay? So what do you think we multiply both the numerator and denominator by? This time the conjugate of the denominator. Square root of x plus 5 plus 2. Square root of x plus 5 plus 2. Okay? So in the numerator, I'm going to leave it as x plus 1 times the square root of x plus 5 plus 2. In the denominator, it's going to be x plus 5 minus 4, which is also known as x plus 1, correct? So the x plus 1's cancel. You stick the negative 1 in the numerator, you get the square root of 4 plus 2, which is 2 plus 2, which is 4. Conjugates. All right, you got to figure it out now after I stumbled and bumbled? Sometimes screwing up is the best learning experience because then you figure out what you need to do and you learn it better. No, that is not why I did that. I didn't mean to do that. Oh, trig identities. Oh, no. Oh, no. All right. Trig identities. You might want to flip over that sheet of your unit circle and write on it because we need to know a few trig identities here, such as sine squared x plus cosine squared x equals 1. Sine squared plus cosine squared equals 1. Well, low-key, that was your sophomore year. And then, let's see if I can remember this. Cosecant squared of x equals cotangent squared of x plus 1. And secant squared of x equals tangent squared of x plus 1. Those are our 3 Pythagorean identities. Okay. Besides those identities, we have our double angle formulas. Okay, double angle formulas. The sine of 2x equals 2 sine of x cosine of x. Our cosine of 2x, there's 3 of them. There's cosine squared of x minus sine squared of x. There's 2 cosine squared of x minus 1. And there's 1 minus 2 sine squared of x. I think that's all I'm going to do for right now because I think those are the only ones that'll appear on this assignment. I think. But I've been wrong before. Really. Okay, you ready? Okay. You weren't ready? All right. Cosine squared. See how we have subtraction down here? So cosine squared, I want to replace that with something. Well, I know sine squared plus cosine squared equals 1. So cosine squared of x should equal 1 minus sine squared of x. So I'm going to because if we put pi over 2 in here, I'm going to get the sine of pi over 2 is 1, and then you get 2 minus 2 is 0 in the denominator. I can't get anywhere. So that's why I'm doing this. So 3 times 1 minus sine squared of x. On the bottom, what can I do to this?
You can take 2 out.
Take out a 2 and I get 1 minus sine of x. Is there any way I can factor 1 minus sine squared of x? 1 plus sine of x, 1 minus sine of x, because it's difference of squares factoring. Okay? And 2 times 1 minus sine of x. So in the end, we have 3 times 1 plus the sine of x, and the sine of x is the sine of pi over 2 over 2. What's the sine of pi over 2? 1. 1 plus 1 is? So it's 3 times 2 divided by 2. 2's cancel, so it's 3. Okay. Sine of 2x, what's its formula? 2 sine of x cosine of x. What happens? The sines of x cancel. So it's 1 over 2 cosine of x. What's cosine of 0? 1. So it's 1 over 2 times 1, which is 1/2. Okay? I know. I know what you meant. No. Okay. Cosine of 2x. Which one should I use if I see something like this in the denominator? Because there's 3 of them. You are correct. We should probably use the cosine squared of x minus the sine squared of x. How is cosine squared of x minus sine squared of x factor? And so if we put pi over 4 in there, it's square root 2 over 2 plus square root 2 over 2, which is 2 square root 2 over 2, which is just square root 2. Last one, cosine of 2x. Don't want to use this one. So what should I use? 2 cosine squared of x minus 1. Because that looks a lot like the denominator. Oh, I guess they use thetas, but if you use x, that's fine. So all we have to do is do differences of squares. Square root 2 cosine of x plus 1 times square root 2 cosine of x minus 1. Boom, boom. Stick in pi over 4. Cosine of pi over 2 is square root 2 over 2. So it's square root 2 times square root 2 over 2 plus 1, which is 2 over 1, 2 over 2, I mean, which is 1 plus 1, which is 2. All right. So that's the basics of the first section that you'll be doing. I'm going to give you probably 10, 15 minutes after lunch before we start our next lesson to work on this, and then we'll do one more lesson.